So in this case, we have got our paper 2 revision as a continuation from the one that we worked, the paper 1. So that was our paper 2. So we want to see that was 2 hours, guys. All right, 75 marks. Okay, so we just gonna go through these questions, try to figure out how you were supposed to attempt the typical questions. So we were given that is okay. All right. Make sure that you go through your instructions. If necessary, round off the answers to two decimal places unless stated otherwise. Number the answers correctly according to the numbering system used in this paper. All right. All figures or diagrams are not drawn to scale. So they gave us questions which is on section A, multiple choice, and we are given a condition. All right. All right. Let us see. Section A, question 1. Identify the figure in which B1 and B2 are complementary. Complementary angles, these are two angles which add up to 180. Two angles which add up to 180. We are talking about two angles there, which add up to, hey guys, 90 degrees. Where am I getting 180? Two angles which add up to 90 degrees. All right. See, guys, this thing of doing a lot of question papers in a single day, end up like, what is happening? All right. Anyways, this is it. Guys, you'll be requesting a lot. So, what can we do? We have to bring you what you want. You are the viewers, you are the Maison African Motives family. Anyways, that was it. Two angles. They are supposed to be two, which add up to 90 degrees. All right, so let us consider. So if we are to consider the first one, all right, B1, B2, how are they related? They are on a straight line. These, they add up to 108, two angles, which add up to 180 degrees. Those are supplementary, these ones. All right, so these are supplementary angles. So there is nothing about complementary there. Okay, B1 and B2 on B, these, they do not form 180, they do not form 90, we do not have a straight line, they do not form 90 degrees, guys. They are just two angles which are adjacent to each other. We cannot say anything about this. They are just adjacent to each other. Then on C, there is B1 and B2. There is an indication of a 90-degree angle here. So if I'm to take angle B1, I add it to angle B2, I'm supposed to obtain the 90 degrees, the right angle that I'm given. This is exactly what we want. Complementary angles, two angles which add up to 90 degrees. So the best answer was going to be C. All right, B1 and B2 on D, these are vertically opposite angles where two straight lines intersect. Vertically opposite angles are equal. All right, so the best answer for complementary was going to be on what? On C. All right, let's consider another part of our question, question 2. What is the size of FOE, the angle FO to E? All right, guys, as we can see from F to O to E, this is a straight line that is being formed. We are simply having a straight line. So angles on a straight line, guys, that is what? That is going to give us 180 degrees. We're talking about angles that are on a straight line, FO to E. All right. But in this case, if we are to consider to say it's 180 degrees, again, it can be something else because they gave us 87, they gave us 45, 45, meaning to say this is not a straight line. If we are to add these angles together, let's confirm, we're going to see that they do not add up to that. So you're just going to add 45 plus 45 plus 87. This is going to give us 177 degrees, which is according to the answers that we are given. It's not there. So, guys, some of these mistakes that they do, because a student can even work out from that and see it's not even there. So the best answer was just going to be of a straight line from what we are given. This is just on a straight line, which is 180. These angles that we are given there, they are wrongly presented. So meaning to say, the best answer there was going to be on what? Was going to be on B. All right, we're going to consider the B there for a straight line. Then 3, what is the size of the outer angle? The outer angle, if this is 90, all right, this is right angle, guys. So from 360 degrees, we're going to have the remaining angle, 360 minus 90, which is what? 270 degrees. So the best answer was going to be on what? On C. All right, let's consider what is the volume of the rectangular prism below. Remember, volume of a rectangular prism, that is the base area times what? Times the height. Length times breadth times the height, or you can use length times width times height. So that is the condition from one part that we are given to the other section. So we can consider our rectangular prism will be given something like this. We'll be having a rectangle down here. So the area of the rectangle, which is length times width. So that is the area of the rectangle, length times width. Whatever that we're going to have, you multiply to the height, which is what? Which is 5. We've got the volume. So that's it. 10 times 2, which is 20, then 20 times 5, that was going to give us what? 100 cubic centimeters. So the volume, the best answer there was going to be on what? On D, which is 100. Then question 5, given this triangle where we've got 20, 12, and 14, which of the following is similar to the given triangle? Remember, similar figures, they're equiangular, which is fine. We can consider in terms of what? Equiangular, to say the angles are the same. Or we can consider in terms of the sides, how they were increased from one triangle to another, or how were they decreased. So this one, we can simply test the triangles as they are corresponding. Do you have any part where the ratio is reducing in the same manner or is being increased in the same manner? All right. If we check the first one, we have got 10. Here it was 20. All right. So if we say 20 divided by what? By this 10, we're going to get a 2. If we take this 12, this side of AC, to this one, 12 divided by 20, we see, guys, we're not going to get a 2 there. So this one is not similar. It must give us the same ratio. We are not given angles, so we have to work with what? With sides. Let's check B. This is 20, this is 10. So if we divide 20 divided by 10, that's a 2. This is 12, this is 6. 12 over 6 from this triangle to what you're given. All right, so that's a 2. This is 14, this is 7. 14 divided by 7, that's a 2. So as you can see, we have got the same ratio. So meaning to say it was reduced in the same ratio. That's a similar figure. If you check the other ones, they are not going to give us anything that is the same. So the best answer there was going to be what? On B, where the triangle was being reduced in the same ratio. We've got same ratio throughout. The ratio of sides is supposed to be the same for similar figures. Then question 6, find or determine the value of x if RT is a straight line and there's an angle of what? 50 degrees there, this one. So we've got RT, a straight line. So x, as we do understand angles on a straight line, they add up to 180 degrees. So x is going to be 180 minus the other angles that we are given, the 50 degrees, and the right angle here indicating what? 90 degrees. So that's it. We're going to have our x from there. That's angles on a straight line. All right, angles on a straight line that we have there. All right, so that is it. If we add, that's going to be 140. So x is going to be 180 minus 140. which is going to be what? Which is going to be 40 degrees. But as we can see, they do not have an exact answer to say the answer is 40. They just gave us 90 minus this. So we just have to figure out which one is correct. Is it 180 minus 40, which gives us this 40, which we do not have on our statement. They do not have something like 180 minus 140. As we can see, it's 180 minus 40, which is wrong. 180 minus 50, which is wrong. So the 180 minus 140 is not there on our answers. So what is it that we just have to check our answers now, because we did the right thing, but it is not presented here. So what are we going to do? We check how they presented. If this angle is 90 degrees, if this angle is 90 degrees, what does it mean? It means the remaining angle here is also 90 degrees. Remember, angles on a straight line gives us 180. So 180 minus 90, it gives us what? 90 degrees. So therefore, x can be obtained from 90 degrees and 50 degrees, because we are saying 50 degrees and x gives us 90 degrees. So x is equal to 90 degrees minus what? Minus the 50 degrees that is remaining, which is going to give us 40 degrees, just like the same answer that we had there. So the best answer, according to how they presented the answers, was going to be A. You answer, guys, according to the way that you're given. They gave you the answers. You do not answer the way that you want to say, I'm supposed to have fought where there is no fault. All right. Number 7, which statement best describes an isosceles triangle? The one that we do know, two sides will be equal, and as we do understand, the angles opposite to those sides are equal. So here they're saying one angle is 90 degrees. That's wrong. We cannot say it's the best property. One angle is greater than 90 degrees. We cannot say it's the best. Two sides and two angles are equal, which is exactly what we have. Two angles opposite equal sides are equal, all right, which is correct. But here, this one is best because two sides and two angles, two sides and these two angles are equal. So the best one, according to what we are given, was going to be C. It best describes what we actually call an isosceles triangle. A triangle has a perimeter of 50 centimeters. Width is what? 10 centimeters. What is the maximum area of that rectangle? A rectangle, if it has got a perimeter, remember perimeter is the distance right round. So perimeter is 50 centimeters. And the width, we are just given the width 10 centimeters. We do not have the length. They're asking about the area. Where area we do understand is length times width. We have the width. We do not have the length. So where are we going to have the length? From the perimeter. From that, because perimeter is equal to 2 into length plus what? Plus width. So we can substitute 50 for perimeter is equal to 2 into length plus our width, which is 10. So we can expand. It's up to you. 50 is equal to 2 times L. That's 2L plus what? 2 times 10, which is 20. Take this one to the other side. It was going to be 50 minus 20, which is what? Which is 30. So 30 is equal to 2L divided by 2 by 2. That's going to give us the value of L there, which is what? Which is 15 centimeters, all right? So the length of this rectangle, we know it's 15 centimeters. So therefore, our area is going to be what? Length, which is 15, times the width, which is 10. So that's our area, 15 times 10, 150 square centimeters. So the best answer where we have got 150 is what? Is on B. All right, so that's it. You just have to figure out from the information that you are given, what is it that you're given, what is it that you can calculate from that. On number 9, we are given that Why is C 45 degrees? Why is this angle 45 degrees? As we can see, these lines are parallel and we form what? A Z. Those are alternate angles where we form a Z. Alternate angles are what? Are equal. So the best answer is going to be alternate angles. All right. So the alternate angles is there on A. Alternate angles as AB is parallel to CD. Okay, that's correct. That is what we had on this one. Then 10, A, B, and C, D parallel to each other. A, B, and C, D, they are parallel as we are given. Then triangle this GMH is an equilateral triangle. What is the value of X? All right, X is here, okay? So we can say, since we've got an equilateral triangle, we do understand each and every angle that we have got inside an equilateral triangle will be 60 degrees as they are equal, 180 divided by 3. So each angle is what? 60 degrees. This can help us to find the 4x plus 20 there to be equal to this angle that is remaining on H1. If H1 is 60 degrees, we can determine the remaining one, which is GHD, or we can just call it H2. Angles on a straight line. So 180 minus 60 degrees is 120 degrees from what? Angles on a straight line. So that is going to help us to determine this value of X. Why? Because we do understand that if two lines are parallel, what is happening on 4x plus 20 and 120 degrees is the condition of our corresponding angles. One is inside, one is outside, corresponding angles, and we do understand that they are equal. So that is what we're going to do. 4x plus 20 and what? And the 120 degrees, which is our H2, they are exactly the same. They're equal. It's an equation. Solve for x. So 4x is equal to what? 20 to the other side was going to be a negative there. So 120 minus 20 is going to be 100. Then divide by 4. So our x was going to be what? 25 degrees, okay? So that is what we're going to have, 25 degrees, and the best answer we've got 25 is on what? Is on A, all right? That is what we are having on on question 10. Then question 2, given 2.1, calculate with the reasons the sizes of the following marked angles, all right? So there are so many. We've got A, we have got B, we have got C, and D. Those are the marked angles, all right? So let's start with the A. We can see that there are lines which are parallel, AC and ED, they are parallel. These two lines, they are parallel to each other. And there is B, which is our transversal line. And as you can see, we are forming what? F angles, corresponding angles. One is inside, one is outside. So 110 corresponds to A plus what? A plus 10. So in that case, you are going to consider that A plus 20, is equal to 110 degrees. So the reason is that we have got what? Corresponding angles in that case, all right? Corresponding angles as the line AC is parallel to ED, like that, okay? So you can solve for X. For A, 20 to the other side was going to be a negative 110 minus 20 degrees, which was going to be what? 90 degrees, all right? So that is what you're going to have as of the value of A, which is 90. Okay, then for B, we can see that we have got that corresponding angle concept because we have got lines which are parallel, G, K, and BH. And we have got corresponding angles. This one and the 2B, they are corresponding to each other. We still have this part of an F. One is outside, one is inside. So they are also corresponding angles there. So that is 90 plus 20 is what? Is 110 degrees. So 110 degrees is equal to 2B. We are talking about what? Corresponding angles, as I explained, since BH is parallel to what? Is parallel to GK, like this. So thus we can find B by simply dividing by what? By 2 by 2. That was going to be 55 degrees, all right? So B is 55 degrees. Then to find C, we can use angles on a straight line. All right. Angles on a straight line, C is equal to 180 minus 2B. Angles on a straight line. Angles on a straight line, where the straight line in that case, where 2B, I mean, where the B here is what is 55. So I can easily use that one, the one that we calculated, 2 times what? 55, which is 110. 180 minus 110, which is what? 70 degrees. So that was going to be 70C. So that is it, guys. As we can see, we've got B, we've got our C and our A. Then D. All right, D here is simply vertically opposite angles, guys. As you can see, two straight lines intersect. So those are vertically opposite angles. They are what? They are equal. So D is equal to 110 degrees. We are talking about what? Vertically opposite what? Vertically opposite angles there. So that is it. We've got everything as we were being asked. We've got everything. All right. So that is where you're supposed to write statement, reason, and so on. So that is it. Find the missing angle with reason. The size of what? X, O, Y, the X to O to Y, this one. All right. Angles at a point add up to 360. So that angle XOY is going to be 360 degrees minus all the angles that are given, which is the right angle indicating what? 90 degrees and the 130 degrees that we are given the sum of angles at a point. All right. So these are angles at a point. They add up to what? 180, 360 degrees. That is a complete revolution that we are talking about. So that is it, guys. You're going to have 360 degrees minus 90 plus 130. 90 plus 130, which is what? 220 degrees. Then subtracting from 360. From 360, it's going to be 140. So that is that angle there, 140 degrees. All right. So that was it for 2 marks. Yeah, for 2 marks, it's fine. Okay, it's fine. It's just application of that. So you're going to have your statement and reason there. Okay, let's complete this statement that is given below. When a polygon is extended, a special angle is formed. Let's say it's a triangle. Let's say it's a rectangle that you are given, whatever shape that you'll be given. But once you extend one of the angles or one of the lines, I mean, a certain angle is going to be formed, which is outside. What is that? It's what? An exterior angle. Angle that is outside. So that's an exterior angle. Find the size or the value of ABC in this fig below for 4 marks, all right? Angle ABC, ABC, all right? So this is the angle that we want. Okay, what can we do? They gave us the 132, which is not even important because here we're just going to say you can use it. But another way also is that angle B and angle C, they are the same. Remember, if you're given these two lines, the angles opposite that, which is angle C, angle opposite to that, which is angle B. So angle B is equal to angle C. The reason being what? These are angles opposite what? Equal sides. All right. So they are equal. Therefore, I can use B in place of C in whatever way that I want. let's say here we want to calculate angle ABC. So ABC, that is, we're talking about angle B. So if we can use the exterior angle 132 degrees to be equal to the sum of the opposite interior angles, it was going to be angle B plus angle C. All right, exterior angle being equal to what? Exterior angle equal to sum of opposite interior what? Angles. So as we stated that angle B and C, they are equal. So in place of angle C, I can use what? I can use angle B. 132 is equal to angle B plus angle B. So that's 2B, which is equal to 132 degrees divided by 2. I'm going to obtain my angle B from there. So that is it. On your calculator, 132 divided by 2 is what? 66. So it was going to be 66 degrees. That is our angle what? ABC. Angle ABC indicating angle B. So that's our angle ABC was going to be 66. All right. So here I'm just using this diagram at once so that we do not have this. I'm going to go back to this. I indicate this. All right. So I hope you understand what I'm doing here. Study the three triangles given below. Give an appropriate name to each of the triangles above, such that each triangle is classified both by its side properties. We are given this one, A. They are showing us that all sides are equal. All sides are the same. This is A, this is A. So that's what? An equilateral triangle. Here it's A, this is A, so these two are equal. This is B, showing that it's different from these two. So these two are the same. That's what? An isosceles triangle that we have there. This is A, this is B, this is C. Everything is totally different. So that's a scalene. All sides are different. That is it. 3.4. Find the value of the unknown angle ABC of the triangle given below. Okay, this is A, B, C. They gave us 10, they gave us 10 here. What is the meaning of that? It means these two sides are equal. This is 10, this is 10. So angles opposite those sides must be equal. Angle B must be equal to angle C. Angle B must be equal to angle C. That is angles opposite what? Opposite equal sides. So if these two are equal, therefore we can write B as C. All right, whatever that we want, we can write angle B as angle C. So it follows that angle B plus angle B plus 72 degrees is equal to 180 degrees. That is angles in a what? In a triangle. Sum of angles in a triangle. So B plus B, that was going to be 2B equal to what? We take the 72 to the other side, that's minus there. So it was going to be a negative 180 minus 72, which is going to give us what? Minus 72, that's 108. So that was going to give us 108. So that's 108. Divide by 2 to find the exact value of B, angle B. So angle B is what? 54 degrees, which is the angle ABC. So that's our angle ABC there. So therefore, angle ABC is equal to 54 degrees. So many ways, guys, that you can simply use. You can simply have angle B equal to 180 degrees minus 72 degrees, whatever that you get, you divide by 2. As we stated that angle B and angle C, they are what? They are equal. So you can simply find it from here. All right. So guys, it's in your hands. It's in your hands. Remember, mathematics, you just have to figure out a way. 3.5. The sum of angles of a quadrilateral adds up to what? Any quadrilateral, it's what? 360 degrees. A triangle is what? 180 degrees. So you must know the difference between these two. Find the value of x from the rectangle that we are given, where with equal diagonals, actually the diagonals are the same. So what will be the value of x? X here. So we know that the angle here is what? The angle here is 90 degrees. That is what we know. The angles. The angle that is at this point is 90. The angle at this point is 90. The angle at this point is 90. All right. There is a 30 degrees that we are given. What can we do with that 30 degrees here? It follows that this triangle that is formed and the triangle here that is formed are exactly the same, guys. So if there is a 30 degrees at D, there's also a 30 degrees at what? At E. Angle E is gonna be 30 degrees as well. So meaning to say we can have the angle F. Remember I said this is 90 degrees of the properties of a rectangle. Each and every angle is what? 90 degrees. So X is going to be angles in a triangle. They add up to 180. So that's 180 minus 30 plus what? Minus 30 plus 90 degrees angles in a triangle. So guys, angles in a triangle just like that. So that is 180 minus 30 plus this is 120, which is 60 degrees. Guys, there are so many ways. There are so many ways. So I want you guys to do those ways. Then you come back to the community section, send your questions, send your suggestions, the way that you think how it's going to be answered. Because we are not doing these questions, guys, for you just to take information just like this, like that. No, learn also as an individual to say that I'm supposed also to do something in terms of the way that I'm given as an individual. Try by all means, all right? Try by all means to figure out some other ways of evaluating certain questions where you have got your own understanding. It can be better. You bring that, then we work it together. So other methods, try to do it, guys. And if they do not match, then let us come back and talk about it. All right. So that is it there. We have got our 3.61, 3.62, angle 4. Find angle 4. This one, angle 4. All right, what can we do? Remember they told us these diagonals are the same. So what we can actually do, there are so many ways. Again, on this one, there are so many ways. So I'm just going to write here so that we do not go back this and that angle 4, 3.62. We need to find angle 4. All right, angle 4, this one. There are so many ways. From G, since this is H. Since we're told these diagonals are the same, GD to H is the same as H to G. They're the same. Given, because we are talking about what? These are the bisectors. So it's already given. If these two are the same, what is that we know about this? We remember we talked about opposite what? Opposite angles to the sides that are equal. They're supposed to be the same. So it means angle D is supposed to be equal to angle G. These are angles opposite what? Opposite equal sides. Opposite equal sides. So it means G is 30 degrees. If G is 30 degrees, we can find angle 1, which is H1. So angle 1 or H1, as we are given, guys, 1 or whatever that you understand there, is going to be what? From 180 degrees angles on a, of which it's not necessary for us even to find that one. But for those who want to calculate it, you can calculate that your angle H1 from 180 degrees angles in a what? Angles in a triangle, 30 plus 30, which is 60, from 180, which is what? 120 degrees. Then to find angle 4, it will be what? Angles on a straight line. So it's going to be 180 minus 120, which is going to give us what? 60 degrees. So angle H4 is simply going to be 180 minus 120 angles on a straight line. So that's the reason that you're going to have there. Or you could have calculated it direct from what? The sum of these opposite interior angles, as angle 4 or angle H4 that we are given there is what? An exterior angle. So it is equal to the sum of 30 degrees plus 30 degrees, which is exterior angle, is equal to sum of what? Sum of opposite interior angles. Guys, it is in your hands. It is in your hands. Whatever way that you want there, still gonna have what? The same answer. So I do not want to talk much, guys. I have talked about these introductions, questions also. So let's also jewel in that, try to figure out as an individual more ways. Complete on question number 4. Two triangles are similar if their corresponding angles measures are equal and their corresponding sides must be in what? Must be in a ratio, these ones. The angles are the same, then the corresponding sides must be in what? In an equal ratio there. Equal ratio. We have got same ratio of sides, or just same ratio are in what? Same ratio. Given that angle P is equal to angle T as given, angle Q and also angle S, prove that the two triangles that we are given, they are what? They are similar. Prove that. So in that case, already we have got angles that we are given. Just going to complete here. In triangle PQ and triangle this, angle P is equal to what? To angle T. It's already given. What about angle S? Angle S is equal to angle Q. It's already given, this one. All right? It's already given. Remember, we are told that angle Q and S. So therefore, these ones, they will be similar because of what? Angle. So here they left another one. We're supposed to talk about this R there. The remaining one, R being what? It's a common angle that we are talking about. So therefore, these will be similar because of what? Angle. That is the reason. Angle. That is the reason. So they left another part that you're supposed to put there for us to put R being what? A common angle. So that's it. Similar figures are what? Equiangular. A surveyor needs to find the distance across a river and draws a sketch shown below. Explain how the surveyor determined the sketch and the known measurement, then find the distance across the river and the known measurement. So explain how the surveyor determined the sketch. All right, so these are just from our properties of our triangles, guys. Do not worry about that. So here it's, what are they saying actually here? And then, and the unknown and the known measurement, then find. So it can be by measurement, then find the distance across the river. So the distance across the river, because we've got this is our river here. So there's a distance across the river. There is also this part, but according to this, we're going to do this one X, the unknown value, which is X. So you have to find that X, which is unknown there. There is 16 meters. 16 meters, it's the height, this one, going up, guys. All right. That is our 16 meters. Then we have got, in this case, the 10 meters is this one going down like this. All right. These two angles are exactly the same. So what we can do is to work with similar figures here. Instead of calculating direct, we can work with similar figures. The triangle, this one, triangle, which is on top. All right. So I'm going to take it in any order. So if I take it like VWQ, that is W, Q to V, W to Q to V. It is supposed to be similar to triangle. W is this one, exactly the same as this other W here. Then Q, which is at 90 degrees, is same as what? Is same as T. V is same as what? Is same as S. These two triangles are similar. It is not by any special calculation. It is from similar figures. That is why they're saying explain how the surveyor determined from what? From similar figures. So you can explain it was obtained what? From similar figures. From similar figures, meaning to say they were equiangular. So to find x, which is this one, the distance across the river, which is the unknown, we can simply use the ratio of sides. As we can see, where x is, it is q to v. That is our x, q to v. So we can form that ratio of sides, wq over what? Wt must be the same as q to v over what? T to S. It must be the same as W to V over W to S. So we can substitute what we have. WQ, we have that one from W to Q. This one is 16 over WT. From W to T, it is 10, which is equal to Q to V. From Q to V, that is what? That is X over TS, which is 20. So I have formed an equation that I can use to solve for what? For X, which you can simply cross multiply. 10 times X, 10X is equal to 160 times 160 times 20. Then we're going to divide by 10 definitely. So that's our X. Depending with your calculation, guys, at the end, you're going to get what? 32, 16 times 2. So that's 32 meters. Okay, that is it from similar figures. They wanted us to use the idea of what? Similar figures. All right, prove that these two figures are congruent. Congruent, all right, we've got two lines which are exactly the same, PQ, so we've got sides here. Let's find angles, if there are any angles that are exactly the same. All right, there are two lines which are parallel here. These two lines are parallel. So it follows that from these two lines that are parallel, TS and QR, angle T and angle P3 will be the same. All right, so angle P3 from what? Corresponding angles. As you can see, we are forming F corresponding angles. So we are talking about triangle TSP and triangle PQR there. So that's angle T and angle S are exactly the same. Angle T is equal to angle S3. That angle S, not S3, but P3. P3. Where am I getting the S, guys? This is P. So that's angle P3. So the reason we're talking about what? Corresponding angles, as we saw that these two lines are parallel, TS and what? And PR, they are parallel. TS parallel to PR. Okay, then we have got another part of parallel lines that we are given. We have got, okay, before that, we have got, remember we said this angle and this angle, the side TQ, TP and what? PQ, TP, TP, and this one, PQ. They are exactly the same, these two sides. So those it's already given. We cannot say there's a reason that it's just given that one. From the parallel lines PS and QS, is there anything that we can relate that we can say it can give us exactly the same if these two lines are what? Are parallel. All right, let's figure out from these two lines that are parallel. We are going to notice angle Q, this one at Q, and angle P1 will be equal. Corresponding angles again. One is inside, one is outside. So angle P1 is exactly equal to angle Q, as I illustrated here. Angle P1 and angle Q, they're exactly the same, corresponding angles. Those are corresponding angles. From which lines which are parallel? from PS and what? And QR, since PS and QR are parallel. All right. So therefore, you can say these two figures are congruent because of what? The reason angle, side, angle. So therefore, triangle TSP is going to be congruent to triangle PQR from angle. We said angle, side, angle, side, angle. All right. Or we can, all right. Or we can use which way, but that is the best one. Angle, side, angle. All right. That is the best. So that is the reason for these two figures to be what? To be congruent. So guys, you see, congruence, you just have to figure out, is it gonna be angle, angle, side? Is it gonna be angle, side, angle? Is it side, side, side? The case of congruence is from how you were relating this information. Okay, so that is how these questions are simply given as. Then question number 5, calculate the perimeter of the trapezium, perimeter, distance right round the shape. But we can see that we are limited because we do not have this side and this side. So let's calculate these sides, all right? AE is 9 meters. AE and BF are exactly the same. These ones, they are the same. So it is 9 meters. So we can calculate AD using Pythagoras theorem in a right angle triangle. So let's calculate sides first. Missing sides. We are calculating the missing sides first, all right? So let's start with AD. From Pythagoras theorem, it follows that AD squared, that's our hypotenuse. Hypotenuse squared is equal to the sum of the squares of what? Shorter sides. So AD squared is equal to AE squared. It is equal to AE squared plus what? DE squared. So that's it. AE, which is 9. So that's going to be 9 squared plus 5 is squared. All right, let's see what we've got. So AD squared is 9 squared, which is 81 plus 25. So AD squared was going to be the sum of 81 and 25, which is 106. So to find AD, definitely to introduce what? The square root there. To find our length of AD, the square root of 106, which is to 2 decimal place, is going to be 10.30. All right, let's just fix this to 2 decimal place. That's 10.30, which is 10.30 meters. Okay, the same thing, we can calculate this missing side because we have got AD. All right, we have got this one. All right, we've got this one, 10.3 meters. Okay, then BC, you can also do the same thing to find BC. From our Pythagoras theorem again, BC, that's our hypotenuse. So BC squared is equal to the square of what? The shorter side, which is BF squared plus what? FC squared. So that's BC squared is equal to BF 9 squared plus FC 8 squared. So that was it. BC squared is equal to 8 squared. I mean, this one 8, 9 squared, which is 81. And 8 squared, 64. Okay, then the sum of these two was going to be what? 81 plus 64. That is going to give us 145. Then we had to introduce the square root in order for us to determine the length of BC, which is the square root of 145. That is to 2 decimal place, 12.04. 12.04. Okay, this one. So this is what we have, 12.04 meters. So we can determine our perimeter, 12.04 here. So perimeter is what? The distance right around the shape. So you were going to combine everything around the shape, right? So this one just helped us to determine this perimeter at the end of the day. So the perimeter of this shape, which is our trapezium, let's add from A to B, which is 20. All right, so that is 20 there, plus B to C, which is 12.04, plus C to F, which is 8, plus F to E, which is 20, plus E to D, which is 5, plus D back to A there, which is 10.3. Distance right around the shape, that you're given. So you can sum up this on your calculator. 20 plus 12.04 plus 8 plus another 20 plus a 5 plus 10.3. So that was going to give us what? 75.34. So that's 75.34 meters perimeter. Just take the units as they are, 75.34. So that was it to calculate those sides. Then after that, you calculate your perimeter. Then the area at the end of the day, the area of a trapezium. We do understand the area of the trapezium from half sum of parallel sides. So 5.12 area, it's half sum of parallel sides, the sides which are parallel, AB plus DC, half sum of parallel sides times the perpendicular height, which is, you can use AE, you can use BF, but this is what? Your perpendicular height. So there we can use AE on our perpendicular height. We can use B to F, anyone. That is our perpendicular height. All right, so let's find that one. So area is half of what? The sum of the lines which are parallel, AB, which is 20, plus D to C, we add. So it's 20 plus 8, which is 28. Then 28 plus what? Plus 5, which is 33. This one. So that is 33. So the whole of this line is what? 33 meters times the perpendicular height going up. That is what? That is 9. So that was going to give us the area, of which this is going to be half of what? 20 plus 33, that is 53 times 9. So our area at the end of the day, you can use our calculator here, 1 over 2. That's 1 over 2 times 53 times what? Times 9, which is, as a decimal, 23 238, comma what? Comma 50, which is just comma 5. All right, square meters, area in what? In square units. So that's our question 5.12 for the what? For the area. You were being asked to calculate the area there. Then 5.2, we had a section, and on that section, they want us to find the area of the shaded portion, this part which is shaded. What is the area? So we can simply subtract the area of the whole shape, which is a square. So the shaded part, so area, which is shaded, we can simply say the area of the whole shape, that we are given, minus the area of what? The unshaded region. That is the condition that we have, which is the whole part that we have is a square. So that's 2 times 2, which is our square. Remember, side squared. Then the region which is not shaded, as you can see, it is just the form of a quadrant. A quadrant, it's a quarter of a circle. A quarter of a circle. So a quarter of a circle, its area, remember, the area of a circle, it's what? It's pi r squared. So when you're dealing with a quadrant, it's a quarter of a circle. It's going to be a quarter, 1 over 4 times that. But if you are to notice again, you will see that there are how many quarters that we have. Therefore, this quarter, this quarter, this quarter, this quarter. So they form what? They form a circle at the end of the day. So that's the area of a circle that we're going to subtract, which is what? Pi r squared. So we are not told about the value of pi to use. So we simply use 22 over 7 or the pi on our calculator. So that's pi r squared. Our r there is the radius. From one corner to this part, it's half of that too. So half of 2, that's 1. So it's 1, 1. So that is 1 squared. So that is it. 2 times 2 was going to give us 4 minus 1 times pi. 1 squared is 1 times pi is pi. So 4 minus pi, like this one, you use the value that you're given, but you're not told about that. So we can use 22 over 7, or we can use the pi as it is on our calculator, shift pi like this, which is going to give us 0.86. So that will be our area at the end of the day, 0.86 in square units. As we are not given these centimeters or what, we're just going to write in what, in square units, as we do understand area is measured in what, in square units. So they can play around, you see, they can play around with that. Then question number 6, complete the table below using the SI unit. So that is millimeters. All right, centimeters, meters, kilometers. All right, so in that case, all right, complete using SI units. So we do not have anything that is meaningful, but we just have to use or relate to what we are given. Remember, in 1 meter, we have got 100 centimeters. So if we check, this is 1,000 meters. This is 100,000. So they simply multiplied. We are measuring with 1,000, or you can measure with 100, any one of these. Because in a meter, we've got 100 centimeters. So if we say 1,000 meters, 1,000 meters, it's going to be what? We multiply that 1,000 meters is going to be 100 times what? 1,000, which is going to be 100,000 centimeters, which is the one that we see here. So we can use that one as a conversion as well to say in 1 meter. What about in kilometers, or each kilometer? If we say 1 kilometer is equal to 1,000 meters in a kilometer. What about 1,000 meters? Because we already given it as 1,000 meters there. So if we know 1 kilometer is 1,000, so it's already that 1,000 meters that we see here. So this is what? 1 kilometer. So 1 kilometer is equal to 1,000 meters is equal to 100,000 centimeters. What about in millimeters? How many millimeters? You can even work with one of these. We can work with centimeters. It's up to you. In 1 centimeter, we have got 10 millimeters. We know that one. In each centimeter. What about in 100,000? In 100,000 centimeters, divide by 10 here. So just remove 1. So it's going to be 10,000. So this is 10,000 millimeters. So in actual sense, it's a conversion for 1 kilometer that we are given here. 1 kilometer is equal to this in meters. It is equal to this in centimeters. It is equal to this in millimeters. They represent 1 kilometer. Convert on 6.2. That is to millimeters. This time it's a conversion to millimeters. All right, let me just leave this one. To square millimeters. 1 centimeter is equivalent to 10 millimeters. We know that. What about a square centimeter? It is, you must square 10 squared, which is 10 times 10, which is what? 100 square millimeters. So when I'm given 37 square centimeters, what about to square millimeters? We must multiply by what? 100. So it's 37 times 100, which is what? 3,700 square millimeters. This is all about your conversion, guys. All right. So this one was all about conversion part. Then 6.3, we have got this figure that we have got a solid rectangular prism, which is 15 by 10 by 5. That is the volume that you are given there. Base area times height. Then he has got a cylindrical hole, which is inside, which has got a diameter of 7 centimeters, which was being drilled out of what? Out of the prism. So this is the information that we had that it was drilled. So the question was now to calculate the surface area of a cube with a side of 13 centimeters. No, this is not the question. This is another question here. This is 6.4. So here there's no question here. In the following, we are given the solid that has got this with a hole which is being drilled on it. So the question, what is the question? Maybe they wanted the volume that is remaining. So there was no question here. But if it was for the volume that is remaining, you calculate the volume of the whole shape, which is a rectangular prism. Then you subtract the volume of what? Of a cylinder. Let's say the question was like that. So you're going to calculate the rectangular, then minus the one of a cylinder. Remember, the rectangular is going to be length times breadth times height minus the length of the volume of a cylinder, pi r squared h. So you're going to use that one to calculate the remaining one, but there's no question. We do not know what they wanted to ask there. 6.4, calculate the surface area of a cube with a side 13. Remember, a cube, all faces are the same. Six faces, there are six faces that we have. So to calculate the surface area, it's simply 6s squared. So it's area of one face times six faces that are there. So that's 6 times 13 squared. All right, surface area complete. It's actually, they gave us something here. Surface area is equal to, all right, so 6s squared. Then you multiply there, 6 times 13 squared, which is 1014. All right, remember I just fixed my calculator there, but it's 1014. Let's use the go back, shift setup, press 8, press 2. All right, so that's 1014 cubic. All right, this is surface area, sorry, square centimeters, area in square centimeters. All right, then 6.5, calculate the surface area of the following cylinder where necessary. Use pi to be what? 22 over 7. So as for a cylinder, we gonna work with what? 2 pi RH. That's gonna be 2 pi RH, the surface area. What is on the surface area, the surface. So they plus what? Pi r squared. Again, we'll actually have to combine the 2 pi RH, all right, and the pi r squared. So when necessary, we are told to use 22 over 7. We've got radius, we've got our height. So let's just substitute 2 times 22 over 7 for pi times the radius, which is 3, times our height, which is 12, plus pi r squared, 22 over 7 times 3 squared. All right, so that's it. You're going to have our area. Let's just find the first one. 2 times 22 over 7 times 3 times 12. That's this one, 1584 over 7 minus the other one, 22 over 7, 22 over 7 times 3 squared, which is 198 over 7. All right, so it's over 7. As you can see, we can simply add the numbers 1584 plus 198. Then whatever that you're going to get, simply divide by what? By 7. So it was going to be 1782 over 7, which is as a decimal, it's gonna be this 254 comma 57. All right, square centimeters. So that is what we're gonna have there. So just check out, guys. Actually, you see I've done a lot of question papers, and also my mind comes tied up. So if there is something that you see or figure out which is not correctly or properly done, let us communicate on the comment section so that we can revisit that question together. But as for now, that is it, guys, till we meet again.